For centuries, natural philosophy has obsessed over living fire. This 16th century woodcut illustrates exactly that, a salamander, which early alchemists classified as a fire-dwelling elemental. We have always wanted to believe an entity could be constructed entirely from flames, but modern physics tells a different story. Standard terrestrial combustion is a purely exothermic chemical reaction. It rapidly breaks apart, dissipating its energy into the surrounding air. Because of chaotic fluid turbulence, a normal fire possesses absolutely no intrinsic structural memory. It cannot hold a shape, let alone sustain a self-organized life form. However, physics does offer a loophole. It exists in a highly complex state of matter known as dusty plasma. This is a quasi-neutral medium made up of free electrons, positive ions, and most importantly, macroscopic solid or liquid dust grains. Unlike the chaotic, wrapping burn of a campfire, a dusty plasma operates as a thermodynamically open system. It exists far from thermal equilibrium. When driven by continuous external energy, like ambient electric fields or UV radiation, the particles transition from a state of chaotic collision into a regime of spontaneous self-organization. When we examine the mechanics of dusty plasmas, we find that the old alchemical myths weren't entirely wrong. We actually possess the strict physical and thermodynamic blueprint required to construct a coherent, inorganic fire body. Any autonomous body requires a way to store structural information, a skeleton or DNA. In a dusty plasma, this process starts when highly mobile free electrons collide with the larger dust grains, giving those macroscopic grains a massive net negative charge. Expect negative dust grains to repel, but positive ions flowing past a negative grain accumulate downstream, creating a positive wake potential. This wake overscreens the primary grain, pulling in trailing negative grains. Instead of repelling, they trap one another. Driven by this continuous trapping mechanism and the directional flow of the plasma, these interactions force the chaotic dust to spontaneously self-organize. The particles link together into stable, three-dimensional double helices that closely resemble biological DNA. As detailed in this text, these helical strings exhibit discrete rotational angles and pitch variations. These act as topological memory marks, encoding structural information, precisely like nucleotide sequencing in biological polymers. This inorganic plasma can actually store information. But an internal skeleton is entirely useless if the body evaporates. Because ionized gas possesses massive internal thermal pressure, it naturally wants to expand outward. Without an active confinement mechanism, the plasma body would immediately suffer structural decay. To survive, the entity must build its own container. It achieves this through localized, self-organized boundary walls known in plasma physics as electric double layers. The plasma builds a spherical boundary, an inner positive ion sheath inside an outer negative electron sheath. This gap's sharp potential drop violently accelerates ambient electrons inward, ionizing fresh gas upon impact. This generates new plasma to balance recombination losses and heal the structure. The literature confirms this dynamic explicitly. The double layer acts as a physical skin. It perfectly isolates the internal high-energy plasma core from the colder ambient atmosphere, maintaining a permanent, stable boundary. If we have an autonomous body with a DNA-like core and a regenerating skin, we reach a mechanical problem. How does an entity suspended in a gas actually move and communicate if it lacks a rigid musculoskeletal system or vocal cords? The solution relies on momentum transfer. High electric fields concentrated at localized points on the plasma's boundary generate strong corona discharges, which violently repel positive ions outward into the environment. This is a process known as electrohydrodynamics, or ion wind. Looking at the electrohydrodynamic force formula, we see the mathematical reality of this propulsion. Accelerated positive ions slam into ambient neutral gas molecules, transferring momentum. This ionic drag generates direct physical thrust, moving the entity without needing mechanical limbs. Furthermore, the plasma body can speak. This inhomogeneous wave equation governs thermoacoustics. By modulating its own internal discharge current, the entity creates rapid heating and cooling cycles in the surrounding gas. This generates instantaneous pressure fluctuations, sound waves, with near-zero mechanical delay. By manipulating its local electric fields for ionic thrust and pulsing its internal heat for acoustic expansion, a purely inorganic plasma body achieves directional locomotion and complex environmental communication without the requirement for rigid mechanical structures. We now have the complete anatomical mechanics for a living fire body, but there is a reason we don't see them walking the Earth. At sea level, the high collision frequency of our dense atmosphere strips away energy too fast, causing rapid thermal equilibrium and structural death. Because this entity is a far from equilibrium dissipative structure, its metabolic rates depend on continuous, high-energy input balanced against very specific environmental limits. It requires a habitat completely alien to human life. This text highlights the exact survival criteria: environments with exceptionally low particle density and ultra-cold cryogenic limits. By minimizing kinetic thermal agitation, the Coulomb coupling parameter exceeds critical thresholds, allowing the plasma dust to transition into stable macroscopic forms required for long-term homeostasis. These precise thermodynamic conditions exist naturally, but only in extreme locations: planetary magnetosmeters, cometary tails, and the vast, freezing expanse of interstellar dust nebulas. When we stop assuming that life requires carbon, water, and atmospheric pressure, the environmental data leads us toward a different conclusion. The deep, freezing voids of space provide the thermodynamic stability required for living fire to exist as a long-lived, naturally occurring entity.